Hello everyone, welcome to another video. In this video, we're going to talk about the specimen paper 4. Most of you guys have been worried about the uncertainty around the component 4, around the paper 4, because the specimen paper is pretty different from the P4s that we have been doing for the last around 8 to 10 years. Right, so let's look at this paper and go through the questions one by one and see what exactly has changed. Okay, so question number one states that liquid Q is a fraction from petroleum containing large alkane molecules. The apparatus is used to crack liquid Q, and the vapor from liquid Q is then passed over the heated aluminum oxide to produce a mixture of hydrocarbons that includes alkenes. The part A says that identify the two pieces of apparatus by completing the boxes in figure 1.1. What is this? This is a stand. Okay, it's also known as a retort stand or stand. Okay, and this is what we call a test tube or a boiling tube. Okay, this is a test tube that is inverted. You can also call it a boiling tube. You can also call it the test tube. Okay, the B part is state the purpose of the mineral wool. Where is mineral wool? Okay, uh, liquid Q on mineral wool. This wool is basically soaking all the liquid. Okay, which then vaporizes and pass over the aluminum oxide. So mineral wool is basically used to soak up the liquid or to hold the liquid or to contain liquid. It is soaking up the liquid Q. You should know that all the wools, if it's a cotton wool or a mineral wool, they're mostly used to soak stuff. Okay, we also studied in rate of reaction methods, loss and mass method, there is a cotton wool at the top. Okay, that is also used to block the liquid droplets that may escape with the vapors, and then you can just squeeze it and those droplets will just fall off. Basically these rules are mostly used to soak up stuff. Give a test and result that shows the presence of an alkene. Here you will write the test, which is you will use aqueous bromine. You will do not write just bromine, write aqueous bromine, and orange or brown bromine decolorizes. Orange red bromine or brown bromine decolorizes. Okay. The next one is state why the delivery tube must be removed from the water when the heating stopped. This delivery tube is saying that when the heating stops, the delivery tube must be removed from water. Yes, once all the gas is passed into the water, then the heating has stopped, right? You have to make sure that you take out the delivery tube. Why? Because the liquid can go back into the delivery tube. So this going back of the liquid is known as the suck back. So what are you trying to avoid? You're trying to avoid the suck back of water. So it has to be removed immediately to prevent suck back of water. See, paper 4 questions are usually very commonsensical. Even if you don't know much, you can still at least take a few guesses. And as far as the apparatus is concerned, just go to the lab and look around the apparatuses. And because they are moving beyond burettes and pipettes and all of that, see, they're asking you what's the stand is. They're asking you what is this. It's a test tube. Then they can also ask what's a gas jar and stuff like that. Stuff that is not normally discussed in classes. So just go to the lab in your school, in your respective schools, and look around the apparatuses. Okay, so in question number 2, a student investigates a reaction between sodium carbonate and two different solutions of dilute hydrochloric acid, which means metal carbonate is reacting with acid, so you are going to get carbon dioxide. So there are two different solutions of hydrochloric acid, solution A and solution B. Both are dilute solutions. Okay, in experiment 1, use a volumetric pipette To add 25 centimeter cube of aqueous sodium carbonate to conical flask. So he added sodium carbonate to conical flask. He added the indicator into it, and then he filled the burette with the acid. Just draw the diagram. I'm sketching the diagram roughly so that you get a basic idea. And I would ask you to do the same in the exam. Just draw the diagram, and this will help you summarize the information that he's giving you. Fill the burette with solution A. What was solution A? This was solution A. It was solution A was of acid, right? And record the initial burette reading. Note the volume here, whatever the volume is in the burette initial reading, and add solution A from the burette until the solution turns colorless. So you will drop it until the solution turns colorless, because you have added which indicator? Thymophthalein indicator, na? So thymophthalein indicator is colorless in acid. It is colorless in acid and blue in alkali. Okay, you need to know all the basic indicators: methyl orange, phenolphthalein, thymophthalein indicator. That's a new one. You should know their color changes, and what are basically the colors in acidic and basic environments. So it had sodium carbonate. So initially, when you added thymophthalein indicator, it would have been blue. So since it has turned colorless, it means that neutralization has happened. Now record the final burette reading. Okay. So what will be the initial burette reading? You'll have to put it here. Initial burette reading obviously would be 0.00. Okay. In experiment 2, empty the conical flask and rinse it with distilled water. Okay. The conical flask that contained sodium carbonate basically. Now repeat the method in experiment 1 with methyl orange indicator. Now you added methyl orange indicator instead of thymophthalein in the conical flask. So initial reading was this and final reading was this. So we use figure 2.1 to complete the table for experiment 2. So I'm just writing down the reading so that because when I'll go to the next page, you'll not be able to see this. This is 12.7 or 8. 12 is 12.8. Initial reading is 12.8 and final reading is 39.2. 39.2. So we wrote the values. The initial reading, the value was 12.8, and for the final reading, the value was 39.2. And what is the volume used? You'll simply subtract both of these values and you'll get 26.4. Now, methyl orange indicator is red orange in acidic conditions and yellow in alkaline solutions. Now, he has been kind enough to tell you this, but he will not always be this kind. Sometimes he's not going to tell you, because so you need to know that methyl orange is red orange in acidic conditions and yellow in alkaline conditions. State the color change observed in the conical flask. Since conical flask had sodium carbonate, which is an alkali, so it will have a yellow color initially. Okay, and once you added the acid, it will change the color to red orange. State one observation other than the color change that is made when acid reacts with sodium carbonate. We know that carbon dioxide is released, so you will can write fizzing or effervescence or bubbling, stuff like that. Okay, what is happening in experiment 3? Now empty the conical flask again and rinse it with distilled water. Now he has emptied the burette as well. Repeat the method in experiment 1 with solution B instead of solution A. A solution B is another solution of dilute HCl. And the indicator that is being used is thymophthalein. And he has given you the readings. Great. Now complete the sentence. Experiment dash uses the largest volume of dilute HCl to change the color of the indicator. Okay, let's see. Experiment 3 used 6.6 and experiment 2 used 26.4, right? Or experiment 1 was 13.2. If you just pause the video and go back like 15 to 20 seconds or just 1 minute, and you can see the value is 13.2. So which experiment used the most volume of acid? Experiment number 2 used the largest volume of dilute hydrochloric acid. State the effect on the volume of solution B used in experiment 3 if this aqueous sodium carbonate is warmed before adding solution B. Okay, nothing really would happen because even if you are heating the solution B, which is HCl, before adding for titration, that will not affect the volume that is being used. Volume depends on the concentration. We know that moles is equal to concentration into volume, and volume will depend on the uh, concentration and moles, and nothing of them is changing when you're heating it. You're basically changing the temperature of it. The maximum it can happen maybe that the reaction rate of reaction would increase, but there will be no effect on the volume, and the reason would be the concentration is remaining the same. Concentration remains the same. Okay, so the G part says that calculate the simplest whole number ratio of the volume of solution A used in experiment 1 and volume of solution B used in experiment 3. So the solution of A that was used was 13.2, that we calculated up from, by subtracting initial burette reading minus final burette reading, and the volume of B that was used in experiment 3 was 6.6. That basically the table that was already filled. If you just go back in the video, you will see the question, or you can simply open the question paper in your phone or whatever, वहाँ से देख सकते हो. तो simplest whole number ratio क्या बनेगी इसकी? 2:1. So basically divide both of these values by 6.6, and the simplest ratio will be 2:1. Calculate the next part is to calculate the simplest whole number ratio of concentration of solution A to the concentration of solution B. You don't really know about the concentration, but you do know that the volume that was used of A was 13.2 and the volume that was used of B was 26.4, which basically means that actually यहाँ से आप ये derive कर सकते हैं that B is actually, since more volume of B is being used, it means that A is a stronger acid and B is a weaker acid, or B has less concentration of acid and A has more concentration of acid. But you know the volumes, so you can actually calculate the ratio. Simply divide both of these values by 13.2 and you will get 1:2. So you can write 1:2. And then he's saying that burette is emptied and reused in experiment 3. In experiment 3, solution B was added, the second solution of HCl. Suggest an additional step after emptying the burette which would improve the accuracy of the results. See, you need to know one thing. When you're repeating the experiment, now, for example, if burette is now being used for solution B, so it's much better if you wash the burette with solution B. It's always good. It's always increase the accuracy if the equipment that is being used, ठीक है, उसमें जो solution आपने next डालना है उससे आप पहले wash कर लो. Okay, because first you wash it obviously with distilled water, right? But you cannot, if you just let the distilled water droplets inside the burette, it can easily fill the concentration of the solution that you put next. Okay, so it's always better for burettes, it's always better to wash it with the solution that is being used next. Like solution B was about to be used in the burette, so it's better to wash the burette with solution B. So you will simply rinse the burette with solution B. Titrations often give inaccurate results if done only once. Suggest how repeating each experiment several times produce more accurate values. See, we keep on repeating experiments until we get similar results. So we get repeating, when you keep on repeating experiment give similar results, and then once you have similar results, similar does not mean exactly similar, it means that closer results, you can simply take their mean or you simply take their average values, and give similar results and average of these results give us give an accurate value or give accurate values. ठीक है, so this was the titration experiment, and surprisingly there was nothing about mole. Normally we used to be displayed a picture of the burette in which you will have to fill the table, initial reading, final reading, and then you calculate the mean values and all of that, and again, and after that there's like 7 to 8 worth marks of sorry 7 to 8 worth marks of moles जो कि इसमें अब नहीं है, which means that they have changed it. But again, you never know. You can go in expecting like you're not going to get moles, but it may happen that they might introduce some moles into it. But do not think that just because specimen paper में नहीं है moles तो नहीं आएंगे. But yes, there is a high chance कि शायद नहीं आए, because the whole point of specimen paper is to prepare you how the next paper would come in terms of the structure. So there is a high chance that moles will not come in titration questions. Okay, so a student tests two solids, solid C and solid D. The test on solid C shows the test, and the table shows the test and the student's observation for solid C. So appearance, it's a green solid, and you have heated it, and the solid turns black. Then you added acid to it. There's a gas produced. So solid can either be a metal or a metal carbonate. Since lime water is being turned milky, it means that gas produces carbon dioxide, and the green solid will be a metal carbonate, right? But if you see, ठीक है, the solution produced in test 2, okay, add aqueous ammonia dropwise and then in excess, a light blue precipitate forms, and it dissolves to form a dark blue solution, which points towards copper. Okay, now test 1 states that the solid is heated, such as fire is necessary to heat gently at first. The sudden heat would cause the tube to rupture. Okay, your solid can jump out of the tube, or the tube might crack. Okay, so the tube might crack. You do not heat it at full throttle. You just increase the heat slowly. Describe how would you use lime water to test the gas produced in test 2. So you'll use the delivery tube. There's a tube called the delivery tube. If, for example, if this has lime water in it, you will. This is called a delivery tube, and you will pass the gas through using. You'll pass the gas through the lime water using this tube. Okay, so this is a 3-mark question. 1 mark is for use the delivery tube to pass the gas. To pass gas through lime water through lime water लाइम वाटर बता दो कि कहाँ पे होगा लाइम वाटर in the next flask. You can also draw a small diagram like I did, and you can tell them like this is the delivery tube, give them basic idea what exactly you're trying to pull here, and this is a flask. I mean, this is a very poor depiction. You can draw a neater diagram. Draw a conical flask भी draw कर सकते हैं. You can draw a flask like this, dip the delivery tube inside, and you will see that this is the gas, and this is the delivery tube, and this is the flask. Identify the gas produced in test 2. It was carbon dioxide. I identified it initially. Okay, identify solid C. So it was a metal carbonate, and we know that obviously light blue precipitate is forming, so the metal is copper. So it will be copper carbonate. Okay. Another idea, another actually hint for you to for it being a copper is that on heating it has turned black. You should know that copper oxide is black, and when you copper carbonate is heated, copper oxide and carbon dioxide is produced. You should know that copper oxide is black. Okay. Some students might confuse it. That's a green solid. The green mean it can be an iron, right? And even iron oxide is blackish. But here is your test. The test 3 actually confirms that the metal is light blue. We know that copper sulfate is blue, but we don't know that copper carbonate is blue. Okay, so be very clear. This is actually 3 tests for only one solid. So these 3 tests will help you shortlist it to copper. I hope you have understood it. Moving on. Okay, so the next part of this question is test on solid D. We just discussed the test on solid C. So solid D, he has actually told you that it's potassium iodide, and solution. The student makes an aqueous solution, solution D, that is basically aqueous potassium iodide, and divides it into two portions. So the first portion of solution D, what did he do? He added sodium hydroxide. Complete the expected observations. Sodium hydroxide does not react with potassium iodide, so really no change, no observation, or you can write no change, no reaction. The student tests the second portion of solution D to show the presence of iodide ions. Give the test and the result that shows the presence of iodide ions. So that is actually the test. We know that the testing for anions, and for iodide ions you'll have to add acidified silver nitrate, or you can write nitric acid. The test is nitric acid and silver nitrate. So silver iodide is formed, which has yellow precipitates, right? Uh, I hope that you guys know that in paper 4 you guys will be given the tables. You don't have to memorize the identification of cations, anions, and gases and all of that. But you still have to memorize it for P1 and P2, so there is no point. मिलते हैं नहीं मिलते, it doesn't matter because याद तो आपको करनी पड़ेंगी. The student does a flame test on solid D. It's potassium iodide. So flame tests are basically done on metal ions. Complete the expected observations. So potassium produces a lilac color. Okay, potassium produces a lilac colored flame. Describe how to do a flame test. How do we do a flame test? We use a clean, inert wire soaked in a metal solution, right? Then put the wire into the flame, into the hot flame. In fact, if you're using wire, uh, anyway, into the hot flame, and then you will observe. I hope you guys have done flame tests in your labs. Okay, and observe the flame color. Observe the flame color. That's how you do. Basically, there are 3 steps. Use a metal wire. Okay. You can also use a metal wire with a solid sample. You don't have to dip it into a metal solution. You can actually use a clean inert wire with solid sample. Actually, just not dip it in metal solution. A better way to use a clean inert wire with a solid sample, and then put the wire into the hot flame, and that solid sample would obviously burn, and then it will give you a very distinctive color. Plant leaves contain a mixture of colored substances. Plan an experiment to find the RF values of the colored substances present in plant leaves. Your plan should describe the use of common lab apparatus, plant leaves, sand, ethanol as a solvent, and the absorbent paper. Okay, sand, ethanol as a solvent. Okay, sand and ethanol is being used as a solvent. And absorbent paper. You may draw a diagram to help answer the question. You may. You don't have to. You may. So you have basic. What you have is basically you have leaves. So obviously you cannot use leaves directly. You'll have to grind them first. So first thing first, uh, you can grind or crush the leaves. It's a 6-mark question. So write 6 points. Crush the plant leaves. Uh, how would you crush it? With mortar and pestle. With mortar and pestle. I hope you know what is this. If you don't, just Google it. आपकी अम्मा के पास ये लाजमी होगा. Crush the plant leaves with mortar and pestle, and you should mix it with sand and ethanol. Sand and ethanol, because he told you that that is the solvent here. Okay, once you've done that, you need to draw the origin line. Draw the origin line on the paper with a pencil. Okay, then apply this extract जो आपने लीफ से निकाला है. Apply the extract on the origin line. Just write the whole process step by step. Apply the extract on the origin line. Once you're done with that, you'll have to dip the paper in the solvent. So you'll write dip the paper in the solvent such that origin line is above the level of solvent. Origin line is above the level of solvent. Has to be above the level of solvent. Otherwise mixing would happen. Now so far what you have done is you have taken a paper, you have actually crushed all the plant leaves and have gotten the extract, and then you put the extract on the origin line, and then you dip that paper into the solvent. Now separation hasn't happened so far. Until here you can get 4 marks. After that you will write as solvent travel up the paper, separation happens. As the solvent travels up the paper, note its final position. Note the final solvent position, or what is commonly known as solvent front. Note the final solvent position. What exactly was the question? What exactly was he asking you? He was asking you to describe the use. He was asking you to plan an experiment to find the RF values of the colored substances in position. Okay. Now, RF values of colored substances, of dyes or colored substances can be calculated by the formula. Just write the formula here. That RF is equal to distance traveled by dye. Distance traveled by dye, or you can write distance traveled by substance as well. Distance traveled by substance over distance traveled by solvent. Distance traveled by solvent. So what exactly did I do? If I have to draw a diagram for it now, I took a chromatography paper draw the origin line, right, with the pencil, and then I put the extract on the origin line. Then I dip this paper uh, in the beaker, in the solvent, such that this origin line is above the level of solvent, origin line or baseline. It must be above the level of solvent. Now the solvent will travel up and this will be separated into its dyes, and you will mark the final solvent position, or what you call the solvent front. And now if you need to calculate the uh, RF values of these colored substances, you will use the formula distance traveled by substance over distance traveled by solvent. So you need to understand chromatography properly for you to attempt the P4 questions, because he has now moved beyond the basic questions of chromatography. Now he'll ask you to compare. He'll ask you questions in which your concept about paper chromatography will be tested, which is very simple actually. You just need to know that how do we calculate RF values, and how do we, you know, compare RF values to find out whether a mixture has a particular substance or not. We'll obviously be doing more questions related to paper chromatography. I hope that you've gotten this one, but you should know the basic idea of it. Whatever is the chromatography question is, you should know it will involve drawing a line, drawing the origin line, and sample would be put there, and then you'll dip the chromatogram, or you'll dip the paper in the solvent so that origin line is of the level of solvent, and then you will mark the solvent front, and then you will use the RF values. These 4 or 5 points are going to come in almost every paper chromatography question. So even if it's a 7 mark question or an 8 mark question and you're not being able to make sense of it, if you just write these points, you'll still be able to extract some marks. Okay, so this was the specimen paper P4. It was very different, surely, but it was more fun actually, because it is like deviating from the regular pattern of paper 4. If you want to do papers like this, do check out the IGCSE paper 6 component of IGCSE, because it's now following that format. But obviously, you will be doing at least 5 year worth of P4 papers from your own, like GC, from your own board. Okay, once you're done with that, I'll strongly advise you कि आप लोग IGCSE के papers attempt करें, at least पिछले 2-3 साल के. That will really help you bump up your grade. Okay then, see you in the next video.